Our next couple of presentations are going to be in the area of pavement. This next one is entitled Implementation of Balanced Mixed or BMD Design in Oklahoma. The speaker is Kevin Suitor. He's the Asphalt Branch Manager at the Oklahoma Department of Transportation. I encourage you to look at his bio. He brings a wealth of experience of over 30 years of experience, in fact, to the department. So, Kevin, could you come forward?
Well, good afternoon. Like he said, I'm a little bit taller than everybody else, so we'll get up here so everybody can hear me. Kevin Suitor with Bituminous Branch Manager, ODOT, and today we're going to talk about some implementation measures that we've started in the past year. Matter of fact, we're right in the middle of it and going to conclude in the next couple of days and then try and compile some data and look long-term, but we'll go through it. Thanks to David Vivanco, my EI, helped me put this presentation together. Our topics, the big one, well, what is balanced mix design? Why do we need balanced mix design? And then we're going to step through the cracking test, the rutting test, our implementation projects. We're going to talk about the special provision just a little bit, future plans, and then what are we going to do? We're going to go to full implementation. What's that going to take? What's it going to look like? First, what is balanced mix design? So we're going to back up just a little bit. Back in the early 1990s, this wonderful word of super pave came along. We got away from the Texas gyratory and the Marshall hammer, and we decided that we needed to better duplicate what's happening out on the road. So we changed a lot of things, implemented a lot of things, but the final piece of that was the performance test. What do we do? Are we able to duplicate performance? Do we know that our payments are going to last under performance measures? Never did really take off a lot. So forward to the past couple of 3 or 4 years, we've developed a balanced mix design. And what is it? Asphalt mix design using performance tests on appropriately conditioned specimens that address multiple modes of distress, taking into consideration mix, aging, traffic, climate, and location within the payment structure. Wow, that's a mouthful. We got to use the right mix for the right job, right? Low volume, high volume, we want to really take a look at it. What are we trying to balance? We want to balance that fine line between cracking and rutting. Those are probably the two biggest issues that we have in the state of Oklahoma, cracking and rutting. So how do we fix that? We know that on the left, if we go to the stability and get the best mix out there, it doesn't necessarily address the cracking. So if we address the cracking, it doesn't necessarily address the rutting. So what we're trying to do is find this sweet spot right here. This is the sweet spot. This is the balanced mix design. It might not have the best rut numbers, might not have the best cracking numbers, but it satisfies a good performing asphalt. So why? Why do we want to go a balanced mix design? Well, we've got cracking in the state. Everybody's seen this. We have it all over the state. Not so much that depth of rutting, but we also have rutting in the state. So how do we fix that? We go through the balanced mix design. Okay, the testing of the asphalt is where we're going to really start and get going. Right now, we are using the iFit, developed in Illinois, for a cracking test. And you can see that the Illinois test is on the bottom, the ideal test is on the top. Takes a slab, we cut it in half, and we notch it and we load it. We look at the area underneath the curve of the braking. So we're able to perform both tests right now. ODOT Materials is working with industry, letting industry come along and help with the development of these things, help with the numbers that we're looking for, and help see if it's truly what we want to try and go with. Both tests are performed on new and current mix designs. We're trying to build a database. So we're going out and we're collecting mixes as out in the field, even outside the balanced mix design projects that we'll talk about. And we're trying to build that database, and we're going to evaluate this for, are these tests simple? Are they consistent? And are they reliable? Can we duplicate our efforts? And are we getting what we think we're getting? Right now we have a load frame, a saw, and an environmental chamber for the ideal and the iFit. Hamburg and Cantabro, Hamburg loaded wheel tester. We'll show you a picture of it in just a minute. We're doing this now and have been doing it for several years. It's a rut depth. We bring a machine in, we make specimens, we put it in an environmental controlled water bath, and then we run passes on a 158-pound loaded wheel, up to 20,000 times. We're looking for a rut no greater than 12.5. We'd like to see less than about 8. Hamburg can also be used this is some new research in identifying stripping issues. The curve on the Hamburg will come across and then drop off where it strips and turns loose and weakens. And then the Cantabro right now is used to identify the durability and the permeability. You take a puck, an asphalt puck, and you toss it into an LA machine for 300 cycles. Pretty tough test, and then you just measure the loss. Loss between 10 and 12 is going to be the limit. Most of our mixes we're seeing right now are between 7 and 8. So we're doing quite well with that. So we've got the Hamburg machine on the left and then an LA machine on the right. Implementation. Now this is where we can get into it. Implementation, we're really trying to develop a database of our current mixes and the new mixes coming in. We really want to try and see if our minimum specification is going to work, and then we're going to compare it to the field, do some studies. This is going to be ongoing for about 3 to 5 years. But we really want to see if we're going to be able to do it. And then we're starting to ask contractors to bring in mixes when they submit a new mix design, and we're going to start chasing those numbers and see what they look like. Test projects, we have 3 right now. We're checking between, we're putting side-by-side mixes on the ground. Balanced mix design and a conventional mix. We're putting them side by side. We're allowing recycled materials in the surface. At present, ODOT does not allow recycle in surfaces. We're taking a look at this. We're trying to check strengths and the true PG grading of our liquids that are in the surface. We're doing that. We're also going to be looking at the rejuvenators and the grade dumping. If we call for a 70 minus 28 and we put a wrap in with it, a 10, 15, 20% wrap, so can we go down to a 58, 28 and out on the road get a 70 minus 28? So we're also looking at that. And then we're going to monitor the performance. Database. We have over 400 mix designs approved right now and in use. That's a lot. We have 70 active plants, HMM plants. Current mixes, we obtain samples from the plant production. We just go out, say, hey, can we have a couple of bags of mix? Bring it back to lab and push it through the database, through the program. The flexibility index for each, and then eventually hope to phase out the non-balanced mix designs. New mixes, hopefully implement this, and you've got to be able to hit an iFit number and rut as we approve these new mix designs coming in. Hamburg, we're already gathering that data. The Cantabro, we're starting that now. It's going to be an information only, because we don't seem to have a lot of issues with that. And again, it's not a pass-fail at this time. Goals, we want to select a cracking test method. With the iFit, there is some sample preparation to it. You have to cut it in half and you have to notch it. with the ideal CT. NCAT has done a lot of research on this. Going to have to look at it a lot more. With the ideal CT, you take a puck and you put it in the machine and you gather the data. So there's not a lot of sample prep to it. Seems to be a lot easier for maybe a contractor. That's a big thing. We want to be able to put this stuff into the contractor's hand so they can go forward and they understand what they have before they bring it into ODOT. Data on new BIC's performance properties, and then approval at design using the performance data. Our test projects. There's 3 of them: State Highway 20 in Osage County, State Highway 156 in Cade County, and the one that is currently being put down is I-35 in McCain County. 156 and Highway 20 are both complete. Interstate Highway 35 are about a quarter to a third through. We collected our first sample last night, and our next sample will be later this week. Is that right, David? Later this week? Okay, State Highway 20 was a 2-lane road, 2-inch mill and overlay. Average ADT, 4.52 miles. The BMD in the eastbound lanes and the control mix in the westbound lanes. Now, the nice thing about this mix is on the NCAT track in section S1. It will show up. Not only are we loading it here in the state, we're also loading it on the NCAT track. We'll have 10 million easels in 3 years. We know if these things are going to produce. We know how they'll react. And we're looking mainly at the cracking on this particular highway. You can see it. The conventional mix versus the balanced mix design, no wrap on the conventional, 12% wrap. AC content, a little bit higher on the balanced mix design. We're seeing that 2 to 3, maybe 4/10 more AC is required to get the cracking test to pass. Air voids, about the same. IFIT level, you can see our IFIT level is, the 8 is the threshold. We're looking for +8. So conventional mix doesn't make it. The BMD mix does quite well. And then the rep depths, they're about the same. You can see the BMD mix is a little bit higher, which is expected. Conventional mix lying right next to the balanced mix design, and that's some placement. McLean County, I-35, 4-lane interstate, 1.5-inch mill and overlay, 44,500 ADT. It's about 5 miles long. Again, they're side by side. Northbound outside, southbound inside is the BMD, and then inside, northbound, outside, southbound is the conventional mix. Again, this mix is on NCAT section N9, so if you want to watch it, NCAT's website, you can watch all the data collection and how things are working over the 3-year period. We had mainly fatigue cracking down on I-35. There's the volumetrics with it. Right now, the BMD has closed up a little bit. We're setting about a 5.3 to 5.4% AC content. I think it's just the volumetrics have done that. The air voids have dropped down to about 2.5 to 3. So the IFIT numbers were good on both of them, and the ruts were both good. Cade County, State Highway 156. It's a 2-lane road. We put down a leveling course and an overlay. This is our low ADT of 650, 6 miles long. Now this one's a little bit different. We did the conventional mix up on the north half, or the north 5 miles, and on the south mile, we put down 4 different BMDs. The contractor wanted to participate. We put down an S4 and an S5 with a 64 and a 58 both. We just collected the data, the samples, and the data will be available in the next couple of 3 weeks. And then we've got one conventional mix on that. We saw a lot of reflective cracking on that mix. It's got 18 feet of concrete, then 3 inches widened on both sides. So we've got a lot of reflective cracking and a little bit of other cracking, but it's looking good. There's the stats on it, the 76 minus 28. Both mixes look really, really good on it. There's a leveling course down. I don't think we got pictures of it going down, but that's the leveling course down, and we'll get some more pictures of it. Special provision. We've got a special provision out. It's not a published. It's just out there using it on these projects so everybody can kind of get an idea. We need to publish it. We need to check. We need to decide whether we're going to go IFIT or ideal. And like I said, the IFIT passing criteria is above 8. Contabro test needs to make sure we get it. We need to talk with construction and make sure where they feel good on wrapping surfaces, and then higher amounts of wrap in bases with grade dumping or rejuvenators. So we're going to address all that in our special provision. Future projects, man, I would love to see 10 to 15 test projects next year. And I'd like to put them in early on so that they're in the project and they can be bid. I'd really like to see rejuvenators and grade dumping. We're working on trying to get facilities to extract the liquid from the material put out on the road, so we actually know what we're getting out on the road. With wrap in it, it's a guess at best. But we're trying to get that started, working on trying to fund that project. We're going to continue database update, and like I said, we're going to try and issue the special provision and get it up into the specs. 2020 and beyond, going to have the updated database, broaden the test projects, analyze previous projects. By that time, we get the data back from the track, late 21, right? And then a full implementation beyond that. Questions? And I'm early. Yay! Yep. It should address both because we're adding the liquid and testing. We're testing for both, so it should, in theory, address both issues. I mean, that's specifically what we're looking for.
One other question was submitted. Does TSR testing fit into this?
TSR, God, love that subject. TSR, yes, we've got a special committee right now looking at TSR, T283. The test itself is so wide and influenced by so many environmental issues. Yes, we're trying to take a look at TSR and stripping. As I noted back on the rutting test, that the Hamburg can help address stripping issues. We're looking at other alternatives for TSR, maybe go to the Hamburg and identify stripping and take a look at it that way. So yes, but with some caveats. Yes, sir.
Lately, we've been talking about asphalt companies that lay asphalt out on our highways. They have a range of asphalt amounts that they put in the mix, and all along they've been running on the low side of that for economic purposes. Now we're finding out that if we want a better product on the road, we don't want to be running on the lean side of the asphalt amount. Do you concur with that, Becky?
Absolutely, and that's what, over the past 10 or 15 years, I think Ken Hobson did a lot of work there. They dropped the gyration levels, they dropped the gyration levels from 100 down to 50, 60 65 and 80 now. I mean, when SuperPay first came out, I was part of putting down an interstate in Kansas that had gyrations of 200. That's extremely dry. Industry as a whole is realizing that we're not getting enough liquid in. And as you've seen from our designs, it is requiring about 2 to 3 more tin steel to get the cracking done. So the answer is yes, we're addressing that. Other questions? Thank you.